This is magic, when the next is to get symmetrical. We're doing question 12. Kinematics. Question 12. You have a graph of velocity against time, and it looks like this. The graph velocity against time by object moving in a straight line. Show what is the corresponding graph of displacement against time. So we have to identify the displacement of a time graph. The easiest to identify here, let's just label this gradient A, this B, and this C. B is the easiest because we know from a velocity time graph, if velocity is constant, that means the displacement time graph would be a constant slope. Why? The gradients are constant, but the gradient of the displacement time graph gives you your velocity. So if you actually check the answers that's given in the paper, there's A, B, C, D, because of this component here. So this is your B component. Or better yet, so you don't confuse your answer, because the answers are in terms of A, B, C, D. I shall put this as part 1, part 2, part 3. So for part 2 here, we're looking for a displacement time graph that looks like this. And in this graph, option B is wrong because the velocity time and the displacement time are both horizontal straight lines. Now we're left with A, C, and D, and which one will be the correct one will now all depends on how we understand these components here. So if we take option 1 here, so velocity time is a straight line here. If you actually remember the previous videos we had, this is displacement over time. For a straight gradient here, we're looking for something that looks like this. Okay. So remember the final summary in the previous videos. We're looking for something like this, like this, like this. That's the order they usually appear in. And then when we have that as the answer, so okay, I'm going to draw it. Okay, it doesn't look that nice, not drawn to scale. But you're looking for something that is curvy here. And in this case, D cannot be the answer because similar to the reasoning here, in D, it is also a gentle slope similar to velocity time. That means it's out. Now you have two shapes, A and C, which is correct because they both have a curved region and a straight line. Now comes the next component, which is part 3, where you have your velocity time graph, which looks like this. And how does your displacement time graph looks like? If I didn't do this part in the previous video, then this will be a new part where you can put into your understanding of what the graph looks like. But in this case, what would the graph look like here? Gradient is constant, but it is a negative gradient. Okay. is negative gradient. Means we're looking for, in terms of negative gradient, we're looking for some sort of negative value. But careful, gradient responds to acceleration. We don't need acceleration, we need to go backwards. So how do we get a negative gradient? In order to get a negative gradient, the shape of our graph must correspond to having tangents drawn in this direction. If you actually check the graph A and C, you notice something very interesting. The correct answer will be C in this case, where the graph curves up in the smiley face, straight line here, and then over here curves down. The other graph, A, displacement time graph, it has the curve in front, you got the straight component. After that, it curves down. If we do not want to find a technique to go back, we just use logic. For what is the area represented in the velocity time graph? It is your displacement. In this case, this displacement is positive. Okay. What does this displacement show? It shows that in the very end here, there is still a positive displacement. Therefore, agrees with the theory of the area. But if you actually check here, displacement time graph, notice the start point and the end point. They are both at the same region. Means the object has returned to its original location. And displacement here is now, the change in displacement is equal to 0, which does not correspond to the area shown by the velocity time graph. Therefore, C is the answer. For the rest of you, I set a challenge for you. How will you show this graph to correspond to this part? I hope you understand this video. If not, you should play this video.